Welcome to my presentation. In this presentation, we shall see an example related to limits. So let us take an example here. And this example is stating that we want to find the limit. We want to find the limit of a function which is of this kind, x squared minus x plus 1 as x approaches 2. So let us start with graphing this function first. As a first step, we will try to graph this function. If f of x, if we call f of x as a function of x, which is going to be x squared minus x plus 1, and if we were to construct the table of values, if we give values to x and we can find the corresponding values of the function, and let us do that. And f of x is going to be equal to x squared. Let me write this a little bit more clearly. This is x squared minus x plus 1. So if we give values for x, we can find the corresponding values of the function. And if I were to pick some points very close to the origin, if I were to say when the value of x equals to -2, the value of the function is going to be equal to 7. When we substitute the values of x, -2 raised to the power of 2 minus of x minus of -2 plus 1. So when we simplify the math, it is going to come out as 4 plus 3, which is equal to 7. When the value of x is equal to 2 in this given function, the value of the function is going to come out as positive 7. Similarly, when we give the value of x as equal to -1, the value of the function is going to come out as equal to 3. -1 raised to the power of 2 minus of -1 plus 1. When we simplify the math, that is going to come out as equal to 3. When we substitute the value of x is equal to 0, the value of the function is going to come out as 1. 1 squared minus 1 plus 1. 1 minus 1 will be 0. 0 plus 1 equals to 1. So when we substitute the value of x as equal to 1, the value of the function is going to be equal to 1, like that. And when the value of x is equal to 2, when we substitute that into this function, 2 squared minus 2 plus 1. 4 minus 2 is 2. 2 plus 1 is equal to 3. And if we were to give one more point, when x equals to 3, the value of the function is going to be equal to 7. 3 squared will be 9. 9 minus 3 is 6. 6 plus 1 is equal to 7. So we constructed the table of values. Now we can plot these points on a graph sheet. If we were to go to a graph sheet like that, and if we were to plot them out, it is going to look like this. So this is the origin. This is the positive x-axis. This is the negative x-axis. This is the positive y-axis, or we're representing the function here. Function of x, like that, and this is the negative y-axis, so we don't have any points there, so we leave it there. So on the positive x-axis, we'll pick some points, 1, 2, 3, and on the negative x-axis, we'll pick some points. We picked 1 and 2, -1 and -2, and the corresponding values on the y-axis, we're going to pick them as 1, 2, 3, 4, 5, 6, 7, and 8. So let's write them down. 1, 2, 3. Let me write this a little more clearly. 1, 2, 3, 4, 5, 6, 7, and then 8. Now, let us plot these points. When x equals to -2, the value of the function is 7. So this is where we are. When x equals to -2, the value of y or the function is 7. That is what we got. When the value of x equals to -1, the value of the function is equal to 3 on the y-axis. When x equals to -1, the value of the function is equal to 3, so therefore that is the point. When the value, we got that. When the value of x equals to 0, the value of the function is 1. The value of x equals to 0, the value of the function is equal to 1. We are right there, so we got that. When the value of x equals to 1, the value of the function is equal to 1, which we are right there. And then when we got that. When the value of x equals to 2, the value of the function is equal to 3. So therefore, that is the point we want to be at. And then finally, when the value of x equals to 3, the value of the function is equal to 7. So therefore, that is the 7 point there. So that is a point. So let me get another color. So when we join these points, it is going to be a curve, and this curve is called a parabola. So when we join these points, it is going to look like a curve like that, and these types of curves are called parabolas. These types of curves are called parabolas. So now as we can see from the graph that we observe the following things. We observe from the graph that as f of x, or the function approaches 3, as the function approaches 3, I'm going to put an arrow there, as the function approaches 3, as x approaches 2, this is the point we have. As x approaches 2, the function approaches 3. So that is how we want to read this. And as the function approaches 3, as x approaches 2 from either side, the function approaches 3. So we can write the same thing, or we can explain the same concept with respect to limits. We can write the limit of this function as step number 2. Let's write this as step number 2. And then in here, we're going to express this limit of this function, limit of the function x squared minus x plus 1 as x approaches 2. If we were to just physically substitute the value of x in this limit, so wherever we see x, we substitute the value of 2. 2 squared minus 2 plus 1. 2 squared is 4 minus 2 plus 1. 4 minus 2 is 2. 2 plus 1 is equal to 3. Let me put a box around this 3, indicating that as x approaches 2, the value of the function is approaching 3. So that is what it is. That is what we want to say. We're going to demonstrate the same thing by constructing a table of values as shown here. Okay, so let me draw the table of values in here, and then if we were to pick points very close to the x ordinate, we will see that the value of the function is going to be very close to 3 from either side. So we will call this as x. We will construct this table of values. If we give values for x, we can find the corresponding values of the function. In the middle here, I want to start this way. In the middle, I want to call this point as 2.0. When x equals to 2.0, we have seen as x approaches 2, the value of the function is approaching 3.0. Okay, we will pick some points very close to 2 on the just below 2 here on the left hand side. We'll pick some points very close to 2, a little higher than 2 on the right hand side on the x-axis. So let us give some points here. If I were to give a value of x as equal to 1.9, 2.999, very close to 2 on the left hand side, the corresponding value of the function is going to be equal to 2.997. On the other hand, if I were to pick a point very close to 2 on the right hand side of 2, a little larger than 2, which is 2.001, then the corresponding value of the function is going to be equal to 3.003. As you can see, just on the left of it is 2.997, very close to 3. On the right hand side, the value of the function is 3.003, which is very close to 3. Let's pick another point on the left hand side. If I were to pick a point 1.99 for the value of x, the corresponding value of the function is going to change to 2.9701, like that. And on the right hand side, if I were to pick a point a little larger than 2.001, for example 2.005, then the corresponding value of the function is going to be equal to 3.015. These are very close to 3, but either slightly larger on the right hand side or slightly smaller than 3 on the left hand side. Let's pick one other point. If I were to pick a point 1.9 on the left hand side of for the value of x on the left hand side of 2, then the corresponding value of the function is going to be equal to 2.71. And then on the right hand side, if I were to pick a point 2.01, the corresponding value of the function is going to be equal to 3.03, like that. And then we can pick more points, but we get an idea now. So I'm going to put a box around this point here, indicating that as x approaches 2, as we give values to x, as x approaches 2 from either side, the value of the function is going to approach 3 from either side. That is what we want to say. So in here I'm going to say as x, I'm going to draw a line here and then write on this by saying as x approaches 2 from the left, then the value of the function is going to approach 3 from the left as well. I'm going to write this one as f of x is approaching 3, like that. Same thing, the observation we see from this from this table of values is as x approaches 2 from the right, as x approaches 2 from the right, the value of the function is approaching 3 from the right as well. The value of the function is approaching 3 from the right as well. So therefore, as x approaches 2 from the left or from the right, the value of the function is approaching 3 either from the left or from the right. So this is the way we want to be able to evaluate limits. In my next presentation, we shall see more examples related to limits.